Okay, so the idea here is that anything that you learned before for DC circuits, you can also do with AC circuits. So things like current division and voltage division and nodal analysis, all of those things you can still do. So if you remember, just a quick review of current division. So for current division, if I have a current and then I have two resistors in parallel, and this works fine whether it's resistors or impedances, and I want to find the current through each branch, then the current through branch 1 equals the total current coming into the point where you have the division of the two branches times the resistance in the other branch over the sum of the two resistances. So just as a quick example, if in DC, if I had, well, I just have a current source. Let's say I have a current source of 5 amps, and I have two resistors, 10 ohm and a 5 ohm, then the current through the 5 ohm resistor will be the total current, which is 5 amps, times 10 over 10 plus 5, or 50 over 15 amps, or 10 over 3 amps, or 3.33 amps. And that's what we would expect of the 5 amps. We would expect 2/3 of it to go through the 5 ohm resistor and 1/3 of it to go through the 10 ohm resistor. Except, did I divide that wrong? I think that's right. Okay, similarly with voltage division, and I'm going to include this because you might find it helpful, or might have found it helpful. Have you already turned in electronics homework? Yeah. So, well, anyway, so voltage division, if I have, and you use this a lot in electronics. If I want to find out what the voltage is right here, then, or another way of looking at it is the voltage across the 3 ohm resistor. And the reason why that'd be the voltage right there, because I have ground at the bottom of the 3 ohm resistor. The voltage across the 3 ohm resistor is going to equal the total voltage, which here is 5 volts, times, and then this is the opposite of the current division, times 3 ohms over 3 plus 4 ohms over 7 ohms, or 15 volts over 7, which is whatever that is. Yes?
So if you wanted to find across the 4 ohm resistor, you do 5 volts times 4 over 7?
Times 4 over 7. Or you would take 5 minus 15 over 7, because it has to.
And the same for up top, like you would,
Yes.
it would be like I times R1 instead of R2.
That's right.
Trying to find I2.
Right. Or you could just subtract from the total. So either way. Okay, so now let's take a look at this problem that I made up. And so if I made it up, it has terrible numbers. So let's say I had a circuit and I had, it's supposed to be the sine wave, an AC voltage source here. This is 150 angle 0, and this is 1 ohm. And over here I have an inductor, and I put ground right there for some strange reason. You'll see if you look at the problem the way I worked it last year, I said, you know what, I'm going to put ground at the bottom and then transfer things at the end. But this time I'm just keeping ground there where it is. So that's J2, and this is going to be 3 ohms. And then on this side I have 2 ohms. And I've got a capacitor that's minus J2. And then I have an inductor that's J4. And then a resistor that's 3 ohms. And let's say that I am trying to find the current here, that current, and my directions tell me that I'm supposed to do it using current division, and I'm supposed to find the voltage here. And so that's what I'm going to do. So the first thing to notice is that we can combine all of these impedances into one impedance because they're all in series, so we can add them together. So on this side, we can make that 5 plus J2. I can't combine these because there's a node in between them where ground is. So I can't combine those two. Okay, so I'm going to do some nodal analysis, and I'm going to try to follow my notes, and I'm going to call this VA, and I'm going to call this point VC, and I'll call this node VB. And y'all take a look and see if, for the purposes of finding out the voltage at VA, do I have enough nodes? For the purpose of finding the voltage at VA, I can combine these. Sort of. But we'll see where we go from here. Okay, so coming from VA, the way you do nodal analysis is you do the voltage at where you're starting minus the voltage on the other side over the impedance in between. So I would have, going to the right, I have ground over here, so I have VA minus 0 over 3, plus, going down, I have VA minus VC over 1, and going to the right, I have VA minus VB over 5 plus J2, and that has to equal 0. And I also have that VC has to equal 150, and since it's angle 0, it's just 150, but I can put 150 plus VB. I didn't label it here, but that's plus and that's minus. So that side has to be 150 more than VB. And then from VB, I have VB minus 0 over J2, so that's going to the right. And then the current going up, the current that's going up through this branch, I'm going to start it at VC because that's the easiest way to do it. The current that's right here is the same as the current that's right here. So it's easiest for me to write that current as VC minus VA over 1. And the current going to the left is going to be VB minus VA over 5 plus J2. And that's going to equal 0. So I'm going to pause for a minute and see what y'all think about that, if you like that or not. Does anybody see any mistakes? I do need you to look for mistakes because I made this problem up.
Is there a simpler way to approach this problem besides doing nodal analysis?
Probably. I'm doing nodal analysis because I wanted to show y'all nodal analysis. Yeah, there almost certainly is, but I didn't have time to think about it. A mesh would definitely be easier, but he said that's for the hungry student.
It takes more work. That was it?
Mesh, he said mesh takes more work?
It says in the quiz mesh takes more work, right?
No, I don't know.
I just remember he's hungry.
Okay. All right. So anyway, so now I'm going to take this equation, and I'm also going to substitute in that VC is 150 plus VB. So I'll rewrite it VA over 3 plus VA minus VB minus 150 plus VA minus VB over 5 plus J2 equals 0. And then the trick with this one is having to do it without using the complex number features of your calculator. So you want to try to do as much of it by hand as possible. So one thing that I decided to do was, because of the way it was set up, and I can't guarantee that yours is going to be the same way, I could get things on two sides of the equal sign and cross multiply, and you'll see what I mean by that in a second. So I can write this as VA over 3 plus 3VA minus 3VB minus 450 over 3 equals minus VA minus VB over 5 plus J2. So I got a common denominator for these two, and I moved this to the other side. And now when I combine these, VA plus 3VA is 4VA minus 3VB minus 450 over 3 equals, and I'm going to distribute the minus, I'll just change the direction of this subtraction. I'll make it VB minus VA over 5 plus J2. And now I'm just going to cross multiply. So 4VA minus 3VB minus 450. And this keeps me from having to rationalize a denominator. Times 5 plus J2 equals 3VB minus 3VA. And then you have to do this multiplication, so you multiply 4VA times each term and minus 3VB times each term and minus 450 times each term. And when you do that, you get 20VA minus 15VB minus 2 0.250. It looks like I did everything times 5 first. So I did the reverse order. I did 5 times 4a, 5 times. So I did 5 times each of these things, and now I'm going to do J2 times each of those things. Plus 8 J8 VA minus J6B minus J900 equals 3VB. This is not B, this is VB. 3VB minus 3VA. And then if I bring everything to one side and group things together and get like terms, I get 23 plus 8JA plus negative 18 minus 6JB equals 2250 plus 900J. So that's one equation. And I'll pause for a minute and just let y'all see if anybody finds a mistake with that.
Instead of VA and VB.
That should be VA and VB, yeah.
So could we do that problem without having that VC node in there?
Yes, but you have to, you still have to take into account somehow or another. I mean, like a super node, but can you do that with this? I'm not sure. You don't have to have the C node, but you do have to account for that current. Let's see. The super nodes, let me think for a minute. Let me pause. You have to account for all of the currents coming out and of the node, and you have to have enough stuff to solve the equation. And so you need as many nodes as you need to solve the equation.
Where's the VC equals 150 plus VB? Like,
What I did with that is I just substituted that back in for VC in this one right here.
you just said, what's like the thought process to get that? It's just equal to the voltage source.
Oh, you mean how did I come up with that?
Right. Why's the VB? Like, how does that come into it?
Well, it's because here's VB and here's VC, and so it's on the plus side, so it has to be that many more. Yeah.
So that's just because VB is 0?
No, VB is not 0. If VB was 0, our life would be easier. Our 0 is over here. So it's not that VC, if VB was 0, VC would be 150. And I would not have even labeled it, I just would have put 150. I'm just saying VC is 150 more than VB. Okay, other questions? All right, then I'll take my second equation, which is, and by the way, I'm going to pause for a second. All right. So our second equation was, we had VB over J2 plus VC minus VA over 1 plus VB minus VA over 5 plus J2 equaled 0. And again, I'll replace VC with 150 plus VB. So this is VB over J2 plus VB plus 150 minus VA plus VB minus VA over 5 plus J2 equals 0. And then the way I chose to solve this, because sometimes there can be an easy way to solve things, but you're in a hurry and you just have to solve it the way that you see to solve it. So this is VB over J2 plus VB minus VA over 5 plus J2 equals minus VB minus 150 plus VA. And then get a common denominator, VB times 5 plus J2 plus VB minus VA times J2 over J2 times 5 plus J2 equals minus VB minus 150 plus VA. And then I simplified all of this. And I got 5 VB plus J4 VB minus J2 VA over 10J minus 4 equals minus VB minus 150 plus VA. And then I multiplied both sides by 10J minus 4. And when you do that and group together like terms, you get VA times 4 minus J12 plus VB times 1 plus J14 equals 600 minus 1500J. And then we had our other equation, which was VA 23 plus J8 plus VB minus 18 minus 6J equals 2250 plus 900J. So I wish there was a nicer way to solve these, and there is if you can use technology, but I will solve the top equation for VA, and I get VA equals 600 minus 1500J over 4 minus J12 minus 1 plus J14 over 4 minus J12 times VB. So I just solved the top equation, VA for VB, and then do you know what to do with these numbers? How to turn them into just plain rectangular form? So 600 minus 1500J over 4 minus J12 times 4 plus J12 over 4 plus J12. And when you do that, that gets the complex number out of the denominator. And I don't have exactly all the intermediate steps, but I can tell you that this turns into 127.5 plus J7.5, and this turns into 1.025 minus 0.425 J times VB. So So that's what VA equals, and then you substitute that into the second equation. So you substitute all that in, 127.5 plus J 7.5 plus 1.025 minus 0.425 J VB times 23 plus J8 plus VB times minus 18 minus 6J equals 2250 plus 900J. And then you can solve for VB, and you get VB is minus 24.4 minus 53.2J, and VA is 79.83 minus J 36.66. Now, again, I'm not saying that by any stretch of the imagination that this is the easiest way to do it. It's just the way I started it. So I started it this way, and then I kind of stuck with it. But I will look and see if I come up with an easier way. So this was, just a lot of messy math. But then from here, it's not bad, because now you have VA. So now once you have VA, to get the current in this middle branch is easy. The current in the middle branch is VC minus VA over 1. That's what I equals. And VC was 150
VC was 150 plus zero. Or
One-
plus VB.
plus VB minus VA over 1, which is 150 plus minus 24.4 minus 53.2J minus 79.83 minus J 36.66. It does not look like, it looks like I made a mistake on that. So that, I'm just going to say is I. I don't know what it is. And it doesn't really matter at this point since this is a made-up problem. So that's I. But then what do you do with I? How do you use current division? So then to use current division, you come back and you look at our problem here, and we have our current division would have, I think we wanted the current on this side, yes. So I'll call this one IS. I equals IS times the other impedance, which was 5 plus J2, over the sum of all of the impedances, which would be 8 plus J4. And then you just have to figure out what that is. Okay. So now give me a second and let me look at the problem. So that's all I have for today, and I will have a regular session on Wednesday. I don't know where, because this room is not available to me, and that makes me sad. But thank you all very much for coming.
No, 100%. Appreciate it.
Yep.
Are you Thursdays and